All right, let's talk about one of nature's most mind-blowing inventions, spider silk. We're gonna unravel the science behind this stuff, and trust me, it completely redefines what we think is possible when it comes to strength and flexibility.
You've definitely seen it before, right? Maybe you've walked through a web by accident or seen one covered in morning dew. It looks so delicate, so fragile. But what if I told you that that tiny, almost invisible thread is actually one of the most high-performance materials on the entire planet?
And no, that's not an exaggeration. If you take a strand of spider silk and a strand of steel of the exact same weight, the silk is 5 times stronger. But at the same time, it can stretch to 4 times its original length before it even thinks about breaking. So how on earth is that possible? Let's dive in. Okay, so the first thing you have to understand is that spiders don't just make one type of silk. A single spider is like a walking, 8-legged chemical factory, pumping out a whole range of specialized materials for all kinds of different jobs. Yeah, it's not just for catching flies, not by a long shot. A spider's silk is a complete multi-tool. They've got this super strong dragline silk for their safety lines and the main structure of their webs. They have a different kind for wrapping up prey, another for making protective egg sacs, and even a type of silk they use to parachute through the air. It's a whole toolkit, all spun from the same animal. So the big question is, how does one little animal produce so many different kinds of material? Well, the answer is down at the molecular level. It's all in the recipe. The main ingredient for all these different silks is a protein called Spidroin. Just think of it like a long chain made up of smaller building blocks, which are amino acids. The real secret to how versatile silk is all about how those little amino acid blocks are arranged. And when we look at what Spidroin is actually made of, 2 amino acids just jump right out, glycine and alanine. Together, they make up more than half of the entire protein. And what's so cool is that these 2 ingredients have completely opposite jobs. This is where the genius of the design really shines. The parts of the protein that are loaded with glycine are all jumbled and messy, which gives the silk its incredible stretchiness. But the parts rich in alanine are super organized, packed together into these little crystal structures, like tiny tough bricks that give it immense strength. It's this perfect mix of flexible bits and rigid bits that makes the material so unbelievably unique. Okay, so with this amazing material at their disposal, spiders have become master architects. They create this stunning variety of structures, and each one is perfectly designed for its environment and the kind of prey it's trying to catch. Of course, you've got the classic orb web. This is the iconic wheel-shaped web that you probably picture in your head. It's a true marvel of engineering. It uses strong, non-sticky silk for the frame, and then a sticky, super elastic silk for the spiral that actually catches the insects. Then you have sheet webs, which you probably know better as cobwebs. They might look kind of messy and random, but they're actually a highly effective trap for any insects that are walking or crawling around. The funnel web is a clever variation of that. It combines that flat sheet with a funnel-shaped hideout where the spider can wait. As soon as it feels vibrations from some unsuspecting bug, it rushes out to attack. And get this, some spiders don't even use glue. Woolly webs are made of these incredibly fine nanofibers that actually hold an electrostatic charge. So instead of sticking to prey, they just snag them, entangling them in thousands of tiny little loops. It's a completely different way to solve the same problem. So spiders build these incredible, complex structures. But here's something that might surprise you. For many of them, that masterpiece they built, it's designed to be completely temporary. I mean, it seems so wasteful, doesn't it? Imagine spending all that time and energy building a perfect web, only to tear it all down just a few hours later. But there's a very good reason for this seemingly bizarre behavior. The truth is, a web has a really short shelf life. The sticky glue starts to break down in the sun, the threads get covered in dust and pollen, and the whole structure gets damaged by wind or by prey struggling to get free. The bottom line is, after just one day, a web can lose more than half of its ability to catch anything. So here's where it gets absolutely ingenious. The spider eats its old web. By consuming the old silk, it can actually digest and recycle 80 to 90% of those incredibly valuable proteins. Then it uses them to build a brand new, perfectly sticky web for the next day. It is the ultimate sustainable manufacturing system. We've seen just how central silk is to a spider's life. But here's a bit of a twist.
Modern research is actually starting to challenge the old assumption that the capture web is the single biggest reason spiders are so successful. This quote from a 2021 study really captures this new way of thinking. For a long time, scientists just figured that the evolution of the web was the key innovation that allowed spiders to explode into over 48,000 different species. But it turns out the story is a bit more complicated than that. You see, there are two major strategies for success in the spider world. On one side, you have the web builders we've been talking about, but on the other, you have these incredibly successful groups, like wolf spiders and jumping spiders, that don't build capture webs at all. In fact, studies show that the foraging web has actually been lost many times over evolutionary history. These wandering hunters evolved a different tool, special sticky hairs on their legs that act as a kind of silk substitute for gripping things. And that just leaves us with a fascinating final thought. The web is, without a doubt, an engineering marvel. And yet, evolution shows us that completely abandoning that famous tool and developing a new one was an equally good and incredibly successful path to take. I guess it shows that when it comes to the game of survival, there's never just one right answer.